Hi everyone. Oh wow, the venue from here looks even better. And let's start with the presentation. And what's the goal of the talk today? I wanted to introduce you to the discussion about what I think to be the biggest elephant in the room when it comes to identity attacks. And actually, you can read the very long title in here. We're talking about hardening the infrastructure security against a potential SSO identity provider compromise. But let me start by introducing myself. My name is Francesco Lacerenza, and I work as Senior Security Engineer at doyensec. For those not familiar with it, doyensec it's an offensive security firm based in San Francisco and highly specialized in white box penetration tests. So my day-to-day job basically is reading through the code bases of clients and dynamically finding bugs in the platforms and services which we all use every day, included Teleport actually. And yeah, I also left some social links, so feel free to get in touch with me during the event or after. Why are we here today? We are here because Teleport at the beginning of this year in Q1 came to us with the proposal of this joint research. And you can find here what are the actual outputs. You can see on the left, we have the summary report of the research that was prepared by the Teleport team. While on the right, we have the white paper analysis prepared by doyensec, which is for the strongest technical people because it's 48 pages long. But you can also have the link for it's the third one on the right of the presentation. And the link is for the actual output of the research, which is the hardening checklist. It's one page containing all the checks that you can do on your Teleport cluster to be sure that you reach the level of security in this worst case scenario that we will talk about in a moment. So let's start from the beginning. What is an IDP and why do we care? And I need to go through the basic definitions, even in probably the vast majority of the audience is familiar with the concepts of identity federation and IDP. Briefly, it's just a service usable to manage a user pool and authenticate the users against a set of service providers. What is a service provider? It's just an application logic that will trust the identity coming from the IDP service and will use the data verified from it to create local users. And you might think, where is Teleport in this game? Actually, since we all know that Teleport is feature-rich, Teleport could be both the IDP or the SP, depending on how you configure it. So it can allow you to have an IDP and register in Teleport your own applications and allow users to perform single sign-on towards these applications. Or you can have Teleport be on the receiving side, so the service provider, where it will trust incoming identities from your preferred IDP, like Okta, Microsoft Entra, and many more that are supported. And for this research, we will always refer to Teleport as the service provider, because what we wanted to do is, finding out the hardenings and improve them, actually, when Teleport is receiving identities from the IDP. And yeah, so that's what our context is. But why do we care? It's very basic because, as you probably know, threats against identity providers have been rising over the last decade. And especially because, as single point of authentication, it's also a single point of failure. So if you compromise as an attacker an IDP, you have a blast radius, which is pretty huge depending on the config. So what was the question that Teleport asked us? It was, is it possible to configure Teleport in such a way that you can be secured even in case of IDP compromise? Is it possible to have an extra confirmation layer to protect us and be sure that the attackers will need to breach both the IDP and Teleport in order to get access to the infrastructure? So that were the prerequisites for our research. And I'll just briefly go through the evaluation strategy and the process we used. Here you can see in the slide on the left, we have the IDP levels of compromise, and you can see 3 buckets, actually. Why we needed 3 buckets? It's because while mainly in the news, you will always read the stories like, oh yeah, the Okta admin was compromised, or yeah, the Azure admin was compromised. In reality, the blast radius against the service provider, in this case, Teleport, could come even from a non-privileged account in the IDP. Just to give you a brief example, if I'm an engineer and I have an Okta identity, but in Teleport, I'm a super admin, the attacker just need my identity in the IDP, not all the IDP to get and breach into the infrastructure. So what we had was these 3 different levels. As said, non-privileged ones, privileged account compromise, which is not only the normal admin, but it depends on the IDP because you can have different rolling systems. Like you can have app managers being able to manage the service providers. You can have team leaders that will just manage their own team and add or remove them, and so on. Then we have the third case, which is the worst case scenario, which is actually a vulnerability in the IDP being discovered, and that's the worst case one. On the right, you see the attack scenarios against the Teleport cluster, and you can see that mainly the scenarios identified were around impersonation of powerful or not powerful identities in Teleport, then stealing data, and one of the most important things, in my opinion, being able to downgrade the Teleport cluster security level after a compromise. So what we've done after having this threat vector tree was entering in a process where we just set up a Teleport cluster, a default one, and just connected the most famous IDP supported as a source of identities. And then we went through this process where we would, for each IDP, reproduce each level of compromise, and for each one, reproduce all the attack scenarios, and then note down what was missing. Then we entered this loop where we would just try to learn, to use Teleport better, its feature and its configs to harden against the scenario, and then repeat again. So that was a very long process, and during this process, as I was introduced, we were able to find multiple issues and things to improve in Teleport features that are now in the latest release. And that was basically it. And the output we left with is an hardening checklist, as I said. Today, we don't have the time to go through all the hardenings. So what I will do today is going through the core aspects of the hardenings we came up with, and I will try to pinpoint them to the attacks because I think it's very important, to get an idea of why these hardenings are important for us. Let's start with the most common but yet most important one, is the impersonation attack of a Teleport user. For the sake of simplicity, today let's just refer to the worst case scenario, where we know that the attacker is capable of impersonating any user in the Teleport cluster. But like said before, the IDP level of compromise could be different, but let's just stick to the worst case in this for this presentation. The hardening in this case, it's pretty straightforward and simple, and it's leveraging access requests in Teleport to create an ephemeral admin strategy inside your cluster. So the idea here is dividing your Teleport users in 2 main types. You will have requesters, being able to search through resources and roles and being able to make requests for them. And you will have approvers that will be just able to accept, deny them. We already talked during other speakers already talked to you about the access request. But why it's important in this case to differentiate the requester and approvers? It's important because the best security setup in this case would be having the approvers to be Teleport local users. But that's pretty inconvenient because we don't want to lose the convenience of having the federated identity. We are here to, exploit the maximum of the convenience of having everything already distributed against all the service providers. And that leads us to another very straightforward issue. If we have the approvers being SSO identities, while we are protected from a single non-privileged account compromise at the IDP, we are still vulnerable to the worst case scenario because the attacker can just impersonate requester A, raise the request, then go with the other user, which is an approver, through SSO, and accept it. And the privask, it's just like that. This is just an example. Another case in Teleport would be like using access list. You could just go into an access list owner and then add other people, or you could have other Teleport actions like the possibility to connect the current cluster as a leaf cluster could be used to escalate. So we found many during the research. But everything comes down to the hardening that I'm going to present now, which is the MFA for admin actions. It's a fairly new teleport feature that will basically require, for administrative actions, an extra MFA check from teleport, so from an MFA device that has been enrolled in teleport. And this is actually preventing the case we have seen before, because the attacker won't have the permission, won't have the MFA device to approve the request. And among the actions protected, there are also state-changing actions on the cluster, like the authentication setup. We require MFA, or changing a node-specific configuration, creating new joint tokens, and so on. The list is very long, and we helped during the research to extend this as much as possible to cover all the possible privilege escalations. And so at this point, you might think, OK, we have the ephemeral admin strategy plus MFA for admin actions. We should be done at this point, but the answer, of course, is still not. But before going into the other attack scenarios, we need to do a step back and talk about connector security. Because configuring all the IDPs that you can see here in the slide, Okta, Entra-ID, Workspace, and GitHub, what we've seen is that the main attributes that you will use during an IDP configuration are usually the username and the group from the IDP that you will map respectively to the identity in teleport, and you will use the group for the rolling mapping. What happens? All the IDPs have different attributes you could choose from, and all these attributes may come with a different access control setup. Each IDP has a very different rolling system, and with the rolling system also it comes the possible manipulation of those attributes. So something that you should be very aware of when choosing the IDP and choosing the attributes is who can manipulate those attributes at the IDP level. Because as you can see in the slide, there are IDP admins, group managers, application managers, and then even the SSO users, like in the GitHub example, where the end user can just change its own username, and if it's mapped, that will cause the creation of a new identity. The second thing we need to talk about is the concept of auto-provisioning, which is basically among the core principles of federated identities. We don't want to go and enroll each new identity in each service provider in order to allow them to be SSO identities. We want, each service provider like Teleport to do what when it sees a new identity. Just create the object, the identity object in Teleport, and let them use the cluster depending on the role mapping. It's pretty convenient. It's also among the main features of federated identities, but it's kind of hard to secure in our context for this presentation, because we are talking about protecting even when the IDP is compromised. That brings me to another attack, which is in the attributes manipulation attack case scenarios. And in particular, that's still pretty straightforward as an attack. Let's say we have GitHub set up as an IDP with Teleport, and my identity gets compromised, and I'm an approver. So we have ephemeral admin strategy, we have MFA for admin actions, we did everything properly, like we said until that moment. What will happen? If the attacker just edits my username in GitHub and go through the SSO authentication, there will be a new identity in Teleport, so like after renaming to Francesco XY. What happens? They won't have any MFA device, so they will be able to add one and bypass the MFA for admin actions. So we are back to the beginning of the issue we were talking about before with this auto-provisioning. That was pretty tough to talk with the team, and with many back and forth. What we decided to do in the end was a very clever move. Instead of creating something new, Teleport team decided to extend something that was already existing. It's the device trust feature, which is you can use it to import and manage your trusted devices in Teleport and enforce their usages in specific actions in the cluster. So what was done was just adding a new rule about which the device trust, if enforced at cluster-wide, it will protect also the first MFA device enrollment. So what happens at that point? The attacker, again, even if exploiting the auto-provisioning of federated identities, won't be able to access unless you got your laptop stolen and you leave the password on it. They won't be able to do anything and add the new MFA device and do the bypasses we were talking about before. Let's move to the other important attribute, which is the role mapping depending on the group attribute. As said, all of us in the infrastructure will have teams assigned in the IDP depending on their roles. And typically in Teleport, you will have a direct mapping from the group in the IDP to a Teleport role. What's the issue here? What we found out while configuring the many IDPs is that team leads in all of the IDPs are capable of renaming their own group. So if they manage a group, they can rename it. That brings us a new layer of middle management of team leaders that are capable to exploit some specific configs, which you can see here in the slide. We have an example where in Teleport, using string matching, you can tell the cluster, okay, if the group incoming it starts with DevOps -anything, just assign the DevOps role. That's convenient if you have many DevOps teams. Yet, that will allow any team leader in the IDP level to rename their group name, like in this slide. I don't know why I chose the HR team, but it could be any other team. If the team lead is compromised in this case, they can just traverse to a different role in Teleport by just exploiting the renaming capability. In this case, the hardening is very simple, just using fixed string matching and maybe automating on your side the creation of the policy, but using in the connector level the fixed group name instead of allowing string matching to prevent these lateral movements from middle management. So that was the end for the 4 main attack scenarios that I want to talk about today. And that brings us to a summary of the extra identity confirmation layer, adding also some other features very important for hardening purposes. And you can see here we have the device trust we talked before to ensure that the first MFA enrollment from an SSO identity is secured. Then we have another one we didn't talk about, but it's fairly described in the full white paper, and it's the per session MFA, which is very important in Teleport to protect with MFA, like for the actions one, but to protect the connections, so the T-shell and Kubernetes and the database connections throughout Teleport, also with applications level. And the other thing is the use of web button, which is a stronger MFA standard that allows us, to be sure that we are secure against OTP-based attacks. And the last one, and the most important in my opinion, to prevent lateral movements is the MFA for administrative actions, because like we have seen, it will prevent any change to the cluster configuration. And like we have seen at the beginning, this is one of the most important threats we can find in our threat vector tree. I also wanted to talk a little bit about detection and response. Even though that was not part of our initial goals, throughout this loop of configuring and inspecting also the Teleport code base, we came across a lot of events that are emitted by Teleport. So if you read through our full Teleport white paper, you will see for each threat scenario a list of emitted events with codes in Teleport that I think it would be very nice to have if you want to integrate in your logging analysis and to prepare your detection and response plan. Here I've also listed some very interesting features for detection and response. We have moderated sessions that could be used to jump into live sessions from attackers being within Teleport live. So it's very good to keep track and eye on them in the edge cases and so on. Then we have the out connector management, which is like the worst case scenario, but still it's a possibility. If you know that the IDP is fully compromised, worst case scenario, you can just cut it down and delete the connector itself, or you can leverage the locking system of Teleport if you precisely know the SSO identities that have been compromised. But in this case, I will tell you, with the locking, be careful, because we know that forced out provisioning is possible. So with SSO identity, it's fairly simple to get a new identity in Teleport which is not locked. So we need to be sure about that. And the last one is the access monitoring, which is a fairly new feature in Teleport. And we also explored it during the write-up we made with Teleport for their Teleport blog. You can find few, I don't know if there are the links there, maybe I will add them later, for the two blog posts we wrote about how to detect compromised identities and how to do an effective identity threat response. In both of the cases, we are leveraging mostly the access monitoring features, which allows you to do very rich queries to the events in Teleport and allow you to understand way better, what happened inside your Teleport cluster. So that brings us to the conclusions. Can the service provider, in this case Teleport, defend itself in case of IDP compromise? Not by default, for sure, because that will be against the concept of federated identities. But I think we demonstrated with this research that Teleport has all the features and the capabilities which, if used properly, can definitely prevent the game over case when the IDP is fully compromised. And that comes with the extra confirmation layer with MFA that we were talking about, with the 4 pillars, the 4 main features, and also with the extra proper settings that we need to be careful about when it comes to connector setup and awareness of the attributes manipulation at the IDP level. I think that's it. If there are any questions or thoughts, thank you.